All right, guys, let's do it. So I've got Unity Hub here. So I'm going to create a new 2D URP project, and I'm using Unity 2022.2.1 F1. Cool. So let me name this project Square dash course, something like that, and create it. Perfect. Now that the project has been created, we can start. All right. So the first thing we want to do here is use or import assets that I've provided attached to this lesson. This will help us speed up things here. So let me do so. Okay, here they are. So let me import them and we should be good to go. Perfect. Once it's done, what we are going to do is select File, Build Settings, and switch our target platform to Android. Perfect. Once it's done, let's tackle our first obstacle. The first thing we want to do is grab our player. So for that, I'm going to open the Square Dash folder, Sprites, and drag and drop my slime face here. Not mine, but the sprite. Come on, you got me. Okay, perfect. We can press F in our scene to focus it and disable the gizmos for now. Perfect. Feel free, by the way, to use any other sprite that you would like to, but I'm going to use this one. Okay. Next, I want to make this slime face my player. But if you know me, you know that I like to separate the rendering from the actual logic and the colliders. So let's do so. So let's right click, select create empty parent and call it player. Perfect. This will be our player renderer. Cool. So we want to make this boy move to the right, like the original game. So you have multiple possibilities for that. You could use transform.position plus equals a certain vector, okay? But what I'm going to do here is use the rigid body 2D component. So let's add a component, rigid body 2D, and this will help us apply physics to our character. Perfect. Now if we hit play, of course it's going to fall. So we need to add a ground. So let's right click, 2D object, sprites, square. And this will be our ground. Perfect. Let's reset its transform, move it down by -0.5, no, -1 actually. Perfect. I'm going to make it a little bit longer, so maybe 50 or maybe 1000 actually. Let's make it very long and move it to the right by half of it, so 500. That's too much, so 400 should be good. Perfect. I can also bring it down so that it seems or looks like a ground, okay? Perfect. Let's change its color to something a bit darker, okay, so that it doesn't interfere with our player. Cool. Now, what we are going to do is add a box collider 2D component to the ground so that we can collide with it. And we are also going to do so for our player, like so. So we can now press F to focus the player, enable the gizmos. What I'm going to do is actually diminish the size of the 3D icons. Yeah, here we go. That's better. If you select wireframe mode, you can notice that the player indeed has a collider, the green one right here. And you can actually edit the collider, like so. Here we go. So we now have our player with its collider. So what we are going to do in the next lesson is move it to the right. See you there. Welcome back, guys. In this lesson, we are going to move the player to the right on every frame. So let's do so. Okay. I'm going to create a script folder. So let's create a folder. Let's call it scripts, open it, and create a player controller. So player controller, like so. Once it's compiled, let's attach it to the player. So drag and drop, as simple as it gets, and open it. Perfect. The first thing I'm going to do is add a reference to the rigid body so that I can change the velocity. So let's add a header components. Serialized field, private rigid body 2D rig. Okay. What you could also do, so basically this will allow us to spot the rigid body inside of our inspector right here. Perfect. But what you could also do if you don't want to see it right here is add another attribute to the player controller, which is the require component attribute, type of rigid body 2D. Cool. You can remove the serialized field attribute from here, add the awake method, and reference the rigid body inside of it. So rig equals get component of type rigid body 2D, like so. It does do the same thing without cluttering the inspector, as you can see. So cool. Okay, let's add another header for our settings now. And let's create a variable for our move speed. So private float move speed. Perfect. Now if I go back to Unity, I can edit that speed. Let's set it to 1 to start off. So let's hit play, but nothing will happen. So what we're going to do is go back to our script and not inside of the update method, but inside of the fixed update method, because we are dealing with physics. And if you open your project settings right here, select physics, you can notice that the physics simulation mode is set to fixed update, not update or script. So let's keep it as is. It will help us keep good performances. But at least you know that you can change it now. Okay, perfect. So let's add the fixed update method like so. And inside of here, what I'm going to do is write rig.velocity equals vector2.right. So the right vector times the move speed. Perfect. Let's now go back to Unity. Let's select the inspector. Okay, hit play. And we should see the player move to the right, which is the case. We can now edit the move speed, perfect, increase it, diminish it, and so on. So cool. So using that inside of the fixed update method will make sure that the player always moves at the same speed, okay? So the speed that you're going to specify right here. And we are also going to use the same logic for the jump logic. Perfect. So now that our player is moving to the right, in the next one, let's learn how we can make it jump. See you there. Welcome back, guys. In this lesson, we are going to learn how we can make the player jump. And you are going to learn some pretty neat tricks right here. Okay. So to make the player jump, we are still going to use the rigid body. We want to change or edit the Y property or the Y axis of the velocity now, because in here, we've only changed the X axis. Okay. So here is what we are going to do. First off, let's create a vector2 and call it velocity. At first, we can make it equals vector2.0. It doesn't matter. Right after that, we should make it move to the right, as we already do. So let's write velocity.x equals move speed, like so. And finally, we can apply that velocity vector to our rigid body. So rig.velocity equals velocity. Perfect. Why did I do that? Well, just so that I can actually add or take into consideration the jump speed. Next, we can do velocity.y equals jump speed if we ever need to jump. So let's actually use that. Let's duplicate this line by hitting Ctrl D, perfect, and create the jump speed variable. Perfect. So right now, the player is going to move right and up constantly, continuously. So let's give that a shot so that you can notice it. I'm going to set the jump speed to 1. So let's hit play. And as you can see, it's constantly moving, which is really bad. That's not what we want. It's moving and trying to fall, moving, trying to fall, and so on. So that's not optimum. What we are going to do now is detect input from the player. So here is what we are going to do. If you want to detect inputs from the player, it's a good practice not to put that inside of the fixed update method. Why? Because this is called less often than the update method. The update method is where you want to put your input logic. Okay, so let's do that. If input.get mouse button down at index 0, so this is the left mouse button click, let's actually call a jump method. Okay, let's now create that jump method. Private void jump. Cool. So we could actually edit our velocity right here, but as I've told you before, it's a good practice to apply your physics inside of the fixed update method. Cool. So inside of the jump method, we are simply going to set a boolean to true. And in here, if the boolean is true, so if let's say is jumping, then we want to apply the jump speed. And right after that, we should set the is jumping boolean to false to prevent jumping again. So in here is jumping like so equals true, perfect. And now we just need to create that variable. So you can press Alt Enter and generate the property is jumping, like so. So let's remove actually these lines. We simply need to set it as a field, not a property, and make it private. Here we go. So now all of our logic is correctly set up. We can go back to Unity, set the jump speed to, I don't know, maybe 2, hit play. And now if we click, it's jumping. Let's actually increase it to, I don't know, 10 maybe. Let's press F. Okay, just to focus our player. Let's click inside of the game mode. Okay, seems like it's jumping, but it's falling really slowly, which is really bad. So why does that happen? This is because we set our velocity to vector2.0 at start. We should not use that. We should actually set it to the current velocity to prevent losing the y-axis velocity, which is actually the gravity, if we don't click to jump. So yeah, let's now go back. Let's hit play. Okay, let's click. Boom. Okay, now seems like it's jumping correctly. Let's set it to 10. Yeah, here we go. Okay. It's like it's on the moon. Okay, perfect. But at least it's jumping. The only issue here is that I can click so many times and make it fly. This is not what we want. So in the next one, let's learn how we can prevent that. See you there. Welcome back, guys. In this lesson, we are going to learn how we can prevent the player from jumping so many times while we are clicking. As you can see, it's kind of flying. That's not what we want. Okay. So for that, we need to detect if the player is grounded. And if it is grounded, we can jump. If not, we cannot. That's pretty simple. So let's do it. Okay, so I'm going to right click on the player and create an empty game object. This will be the ground detector, or you can call it feet or foot. Okay, so let's place it somewhere around here. Perfect. And why do I place it here? Just because if the player is on the edge of a platform, so let's say there is a platform, so let me duplicate this. Okay, 1 by 1, 0, 0, so it's right here. Perfect. Now imagine this situation. If the player is on the edge of a platform, we still want to allow the player to jump. It's actually a bit fair, you know, it's better for the player. So yeah, you can decide not to do that. And if that's the case, you can move the ground detector to, I don't know, maybe the center of the player. That way he'll only be able to jump while he's here, okay? So yeah, again, it's a design choice, and I've decided to drop it somewhere around here, so -0.5. Let's reset the player position to 0, 1, no, 0, 0. Cool. And remove this. Here we go. So now that we've got our ground detector, let's implement our logic. So for that, I'm going to open the player controller and add a new method to check if we are grounded or not. So public bool, or maybe private bool, is grounded. Here we go. So let's add a reference to our ground detector here. So I'm going to add a new header for that, elements, serialize field, private transform, ground detector. Here we go. So what do we want to do? First off, let's check if we detect any collider right here, okay? So let's go back here. Let's just return false to prevent having an error, okay? Perfect. So let's first pass in our ground detector. And what we're going to do, because we don't have any layer for now, but I'm going to keep it simple, we are going to use the ground collider to check if we've detected any collider. But don't forget that we also have the box collider of the player collider. So we should prevent us from detecting that. So here is what we are going to do. We need to add a new layer for our ground to be able to only detect ground objects, or objects that are inside of the ground layer. So we already have some. So let's add another one. Let's call it ground. Perfect. Let's select the ground and drop it inside of the ground layer. Here we go. Now inside of our player controller, we can specify that layer. So let's add it. Maybe inside of the settings, yeah, serialize field, private layer mask, ground mask. Here we go. If we go back to Unity, we can now specify this layer. So let's select the player. Let's select the ground layer. Here we go. And we can now detect all of the objects inside of this layer. That is so cool. Okay. So inside of our isGrounded method, here is what we're going to do. We are going to use the physics2d class dot overlap circle. So overlap circle, all or not all. Actually, we have two ways of detecting here. We can use this one or this one. This does return a single collider, and this does return an array. In our case, this one will be enough. Why? Because we only need to check if we've detected one collider that is inside of the ground layer. Got it? If we've detected at least one collider, then the player is grounded and we can jump. So let's use it. Our point will be the ground detector. So ground detector dot position. This is our point, the center point of our detection. For the radius, we are going to use a variable so that we can tweak it. So let's write ground detection radius. And finally, we can pass in our ground mask. Here we go. So I'm just going to create this variable now. Okay, let's drop it somewhere around here. Serialize field, private float ground detection radius. And just for testing purposes, I want to be able to spot it inside of my scene view right here, just by enabling the gizmos. So I'm going to use the onDrawGizmos method to be able to spot it. So gizmos.color equals, let's say, magenta. So color.magenta. Gizmos.drawWireSphere at the ground detector dot position, and its radius should be the ground detection radius. Cool. So let's comment this for now, just to be able to spot it inside of the scene view. Return false. Okay. Let's go back to Unity now. Let's select the player. Okay. And increase the ground detection radius. As you can see, we can now spot the magenta sphere here. If we detect anything inside of this circle or sphere that does belong to the ground layer, then we will assume that the player is grounded. Okay? I hope this is clear. If not, please leave some questions in the comments section. So in here, I'm going to use .05, I guess. It should be good. Yep. And if we don't like it, we can always tweak this value. Okay. So let's go back to our script. Let's remove this. Okay. Let's keep it. And this does return a collider 2D. So what we can do is store this inside of a collider 2D. So collider 2D call equals this, or maybe ground equals this. And we are grounded if this is not null. So return, oh, not like that. Come on, return ground is different than null. And we should be good. So we now have a way to detect if we are grounded or not. If the player is grounded, not us, we are grounded. Come on. So if is grounded, then we can jump. If the player is not grounded, we cannot allow him to jump. Let's go back to Unity. Hit play. Okay, I can only click once. Let me just unzoom here. Okay, let's increase the jump speed to 10 or maybe 5. Okay. And if I click here, I can only click once for him to jump. So cool. Here we go. So that's one big piece of logic that we've added here. That's awesome. So what we are going to do in the next lesson or lecture is tweak the values of our gravity and move speed and so on, just to have a feel closer to Geometry Dash. See you in the next one. Welcome back, guys. In this lesson, we are going to try and have our game feel a little bit more like the original Geometry Dash, because as you can see right now, it's a bit slow and we can't jump really well. So yeah, I don't like it. So yeah, let's change that. First off, what I'm going to do is increase the gravity. So let's set it to -70. Then I want to apply a default material here so that there is no friction at all. So for that, I'm going to open my Square Dash folder, right click, create a new folder for our physics. Perfect. Right click, create a new 2D physics material 2D. And let's call it frictionless. So frictionless. Here we go. I'm going to assign it to the default material here and set the friction value to 0. Now everything should slide. So smooth. Okay, perfect. So once that's done, we are going to select our player and set the following values here. The move speed should be something like 9.5. So of course I already have the values, but I invite you to tweak these and yeah, just to have the feel that you want. So this should be 9.5 and I'm going to use 19 for the jump speed. Again, you can tweak these values and try and get the feel that you want for the game. Cool. So I'm going to unzoom a little bit here. Okay, hit play so that we can just spot the player actually. So I'm going to try and jump a little bit. Okay, yeah, that's what I like to see. Awesome. And as you can notice, I don't know if you can, but when I jump, I do enter the ground for a little bit of time. And that's weird. So here is what we are going to do. For the collision detection method, we are going to select continuous. And we are also going to freeze the rotation of the player. We don't want it to rotate because we are going to rotate the player renderer actually. Okay. So let's now give it another shot. But what we can do first is set the main camera as a child of the player. Perfect. So here is what we are going to see. Let's move it somewhere around here. Maybe 4 and 3 for the offsets. Nice. This is closer to Geometry Dash's look. So let's now hit play. Okay, now the player is moving because if I select it, we can notice that it is. If we jump, okay, nice. That's cool. Of course, we are going to have a better camera controller later on. By the way, I can just keep it to 0 for now, but yeah, the camera controller later on will be much better than this one, of course. Now we are just testing and implementing the main systems. Cool. So what we are going to do in the next one is add rotation to our player. See you there. Welcome back, guys. In this lesson, we are going to implement the player rotation. But first off, I want to do something else that I forgot to do previously. So let's open the player controller script. And I also want to allow the player to jump if we are currently pressing the screen or the mouse. Okay. So in here, what we can do is add OR. So you can use it like so. So 2 bars. Input.get mouse button at index 0. And now we should be good to go. That's so cool. Now, if I go back to Unity, you can notice that even if I'm pressing, so I'm pressing, I'm not clicking now, the player is jumping continuously and so smoothly. We should see him pass. Okay, here it is. Boom, 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 boom. You can add actually some sound effects. Could be cool. All right. So this is working perfectly. What we are going to do now is create a player rotator script. So let's do that. Player rotator. Nice. Let's attach it to the player like so. Cool. And open it. So basically, we will have 2 states. The first one is when the player is not grounded, so jumping or falling. We should rotate it continuously. Then when the player is grounded, it might actually land on the ground at an angle. So we should reset its angle, but smoothly. So yeah, definitely 2 states. So here is what we're going to do. Let's implement the first one first. So we need a reference to the renderer. So elements, serialized field. It's actually a component, not an element. So let's change that to components. Okay, private renderer, renderer. We can actually add the new keyword just not to have issues with Unity. Okay. Okay, so we now have a reference to our renderer. What we're going to do is manage our player rotation. So private void manage player rotation, like so. Let's call this method inside of the update method. Perfect. And we have 2 states right here. So when the player is grounded and when he's not. So if the player controller dot is grounded. So if it's not grounded, what we're going to do is call the player not grounded state. Otherwise, we are going to call the player grounded state. As simple as it gets. So the two states that I told you about previously. Okay, first off, we need a reference to the player controller. So you could either create a serialized field for that or use the logic that we've used previously. So require component type of player controller, perfect. Private player controller, and inside of the awake method, player controller equals get component of type player controller. Here we go. That's one issue fixed. The second one is that the isGrounded method is not public. So let's turn it into a public method, like so. Here we go. That's two issues. Let's now create these two methods. So private void, player not grounded, and private void. Come on. Private void player grounded state. So let's remove the not keyword here, and we should be good to go. Awesome. So if the player is not grounded, what we are going to do is rotate it or rotate the render at a certain rotation speed or angular speed, actually. So render dot local Euler angles, but you need to use the transform here. So transform dot local Euler angles plus equals, we need to rotate it around the z-axis. So vector3 dot forward times the time.delta time for it to be responsive across multiple devices times a certain rotation speed. So let's call it angle increment, like so. Let's now create this variable. I'm going to drop it here. So settings, serialized field, private float, boom, and we should be good to go. Okay. So now, whenever the player is not grounded, so when he's jumping or falling, he should rotate. We can actually give this a shot. So let's go back to Unity. All right, let's add a reference to the renderer. And let's set the angle increment to minus 369. Again, after testing a lot of times, this is a value I came up with, but I invite you to tweak it and test it. Let's hit play. Okay, let's try and jump now. Yeah, here we go. Nice. Pretty cool. I can actually reduce it by a little bit. So let's set it to 0. Let's reduce the angle increment. So minus 350 maybe. Yeah, that's actually closer. Maybe I can still or keep reducing it a little bit. Let's try 348, I guess. Nope, too low. So let's increase it. Minus 351. Yeah, here we go. It's now around 180 degrees. That is perfect. Okay, cool. So we've got the first logic here. So we now need to tackle whenever the player is grounded, right here. So see you in the next one for that. Welcome back, guys. In the previous lesson, we've seen how we could make the player rotate whenever he's not grounded, so when he's jumping or when he's falling. Right now, we are going to learn how we can make it rotate whenever he's grounded. So go back to the initial rotation. Okay, so let's open our player rotator again. So inside of our player grounded state, here is what we are going to do. First off, we need to twin things or values. So the best thing I'm going to do here is to actually use a twinning library. So let me import the lean twin library. A window, package manager. Let's search for my assets, lean twin. And if you don't have it in your assets, make sure to go grab it from the asset store. It's a really important and useful library. Import it. Okay, seems like I already have it. So yeah, let's use it then. Perfect. Let me quickly explain what we're going to do. So right now our player is jumping, and whenever he lands, we are going to grab this angle and look for the closest 90-degree angle to that current one. So right now we are at 160, so the closest one should be 180. Here we go, like so. So we should rotate the player to 180. If the player was rotated by, let's say, 112, we should rotate it to 90 degrees. That's the closest 90-degree angle. Perfect. So let's do that. We first need to grab the closest angle. So float, closest angle. equals. So we need to grab the render.transform.local Euler angles.z. That's the current angle, divided by 90 degrees. Okay? And this does return a floating point value. And we need an integer. So let's cast that into an integer, but not with a typical cast. Instead, we are going to use mathf.floor to int, just to grab the largest integer smaller or to or equal to f, actually. Okay? And once we get that, we are going to multiply it by 90 degrees to get the closest 90-degree angle. Here we go. So that's our closest angle. Now we need to grab the difference between this angle and the current angle. Why? Because we are going to use the lean_twin.rotate around local method. And this does need a game object, an axis, and add. So the add value here is the angle that you want to add to the current angle. This is why we need the difference between the closest one and the current one. Okay? So float angle difference equals render dot, oh come on, render dot transform dot local Euler angles dot z minus closest angle. Here we go. That's our angle difference. Now we can use it to rotate our render. So render dot game object. The axis will be vector 3 dot forward, and we need to add the angle difference. And for the time here, I don't know. Let's turn it into a variable actually. So lean angle time, something like that. So let's create that variable somewhere around here. Serialize field private float. Boom. Yep, we should be good in my opinion. But because we are twinning right here, we need to make sure that there is no other twin currently going on. So let's first cancel any previous twin. So lean twin.cancel render.gameObject. And if the player is grounded, we are constantly going to call this method. And that's bad because we are constantly going to try and twin. So we need to add another piece of logic to prevent that. For that, here is what we are going to do. We are going to create a Boolean and call it isTwinning, okay? And right here, if we are twinning, we are simply going to return, like so. And of course, we need to set our isTwinning Boolean to true right here because we are twinning indeed. And the last thing we need to do is to set this to false. So when do we want to set it to false? Because if we set it to true here, it's always going to be true and we are not going to twin anymore later on. So we need to set it false inside of here whenever the player is grounded. So if isTwinning equals false, but that's not it because we might be twinning the angle and jumping at the same time. So we need to stop twinning the render.gameObject. Here we go. Lean_twin.cancel, sorry. Yep, that's better. Okay, I think we are good and ready to give this a shot. That will be our first step. There is something else after that, of course, always. So yeah, let's give that a shot. I'm going to select the player here. And for the lean angle time, I think I'm going to set it to 0.1, okay? So we should go back to the initial angle or the closest 90-degree angle actually in 0.1 second. Okay, let's try that. Let me jump. Boom. Okay, so there is something bad here. Let me jump again. All right. Yeah, that's not it. What's the issue here? We are actually adding that angle and we should subtract it, not add it. If we wanted to add that angle, we should have the opposite logic here. Closest angle minus render.transform.blah, blah, blah. You got that. Okay, so let's try that again. And right now it should be good. I hope so. Yeah, let's try. Boom. Yeah, okay, here we go. So we are indeed rotating, but too much in my opinion. Yeah, we are rotating too much. So let's fix that again. What does happen here? If I select the render, hit pause. Oh, too slow. Too slow. Up. Yeah. So we are at at minus 3 degrees. If I go one frame further, minus 21. Yeah. That's really bad. We are trying to reach minus 90 degrees. This is because we need to grab the closest angle, but because Unity is weird sometimes with angles, like when you reach 360 degrees, you need to go back to 0, but you need a full rotation. It's actually really weird. Here is a fix for that. We are going to check if the angle difference is greater than 60 degrees or 45 degrees. So that's half of 90 degrees, of course. What we're going to do is write angle difference equals 90 minus the angle difference multiplied by -1. Okay, so this should fix our issue by fixing the 360 bug. Okay, just to have a value between 0 and 360. Okay. All right, let's try that. Let's try and rotate. Boom. Yeah, that's better. Let me try and jump constantly. Okay. Let's try and edit this value, so the angle increment to -180, just to have a look at it. Okay. What about 30 degrees? Yeah, nice. What about, I don't know, 250? Yeah, cool. -250? Perfect. That's so cool. -300? Yeah, that's way better. Okay, so we now have the rotation corrected. There is still one small thing, as always. And of course, regarding this angle thingy, make sure to test a lot, because you might find a better way to do things. Of course, there are always multiple ways of doing the same thing. This is the way I found correct and working, but it might be maybe overcomplicated for what it is. So I invite you to experiment and research any new methods or any other method to do the same thing. Okay. So, yeah, I was talking about the other thing we need to check here. Because if we try and keep pressing right now, it's still going to try and twin. So let me try and press. You see, it's weird. It's like the player is blocked or blocking at some point. And that's kind of bad. So for that, we need to check if the player is pressing. If it is the case, we don't want to apply the twin. So if the player controller dot is pressing, like so, we first want to check if we are twinning. So if is twinning equals false, lean twin dot cancel the render dot game object twin and return. Perfect. This will help us exit or cancel the twin if the player is still pressing to continuously jump. We should still apply this logic if he's pressing, okay? So let's add the is pressing boolean somewhere around here. Public bool is pressing, okay. And in here we should just return input.get mouse button 0. Yep, should be good. Because if the player is currently pressing the left mouse button, it will return true. So let's give that a shot now. Okay, so I'm going to hit play, of course. Okay, let's try and jump. Here we go. The player is not blocking now. That's so cool. But if I release, it's still going to reach a 90-degree angle. Awesome. Really nice. I love it. Okay, so that was it for the rotation. What we can do now is implement a better camera controller and add some platforms to start having a little bit of fun. See you in the next one. Welcome back, guys. In this lesson, we are going to tackle the camera controller, and this is something really important in this kind of game. Okay, it needs to feel smooth, responsive, and follow the player along without interfering with the actual understanding of the player of the environment. Because yeah, this is a fast-paced game. You need to have a look at all of the obstacles, and yeah, all of that to say that it needs to be perfect. Okay, so here is the logic that I'm going to apply here. Again, this is a choice I've made. You can decide to have another camera logic, but I'm going to explain how I've proceeded here. So where is my player? Here it is. Basically, we've got our camera. First off, let's unparent it. Here we go. We are going to have a certain line, but first off, I want the camera to be placed at 3 units above the center position, okay? we are going to have a line somewhere around here, maybe at the center of the camera, so maybe 3 or 3.5, where the camera should not move if the player is below it. Okay, so if the player is below 3.5 units, we should not move the camera along the y-axis, of course. But regarding the x-axis, the camera should always follow the player. Okay. If the player is above this line, so 3 or 3.5, and don't worry, I'm going to draw that line right here, then we should follow the player, but depending on its distance from the camera along the y-axis, just to keep a smooth movement, okay? And for that, we are going to use the late update method, not the update one. Why? Because the late update method is called after the update and fixed update methods. And this is a good place to drop your camera logic here. Let me have a look at the documentation. Here it is. So late update is called after all update functions have been called. This is useful to order script execution. For example, a follow camera should always be implemented in late update because it tracks objects that might have moved inside update. Got it? This is a really important point to note. Okay, so now that we know what to do, let's do it. So I'm going to create a new script. So create a C# script, call it camera controller, something like that, and wait for it to compile. Here we go. Let's now attach it to the camera right here and open it. Cool. So the first thing I'm going to do is add the late update method. That was pretty quick. Awesome. And next, I want to draw that line I told you about. So for that, I'm going to use the gizmos. So on draw gizmos, gizmos.color equals color.green, let's say. Or maybe let's keep green for the colliders. So color.red or yellow. I like yellow. Okay. So let's now draw that line. So gizmos.drawLine. We need to specify the from and to point. So for that, let's create these two vectors. Vector3 from equals vector3 dot up times a certain threshold. So the y follow threshold we spoke about. So threshold, okay, we should be good. Let's create it. I'm going to create it somewhere around here. Settings, serialized field, private float, y follow threshold. Perfect. And I'm going to move it to the left. So from plus equals vector3 dot left times, I don't know, maybe 50 units to the left. And let's now create the two vector. So vector3 2 equals from plus vector3 dot right times 100 to the right. Now we can draw our line from 2. Perfect. Let's go back to Unity. Is it okay, please? Yep, here it is. Here is our line at 0. And we can, of course, increase this value as we wish. So if the player is below this line, we are not going to follow it along the y-axis. But if it is above, then we are going to start following it. Perfect. But if the player goes above, we're going to follow it. And comes back below, we should go back to the initial position. So the initial offset is 3. Got it? So we need to store that somewhere. So let's create some variables for our basic offsets here. Let's go here. Yep. Serialized field, private float, x offset, and another one for the y offset. Like so. Perfect. We can configure them already. Right here, let's set them to 4 for the x-axis and 3 for the y-axis. When it's compiled, of course. Here we go. So 4 and 3. Perfect. So inside of our late update, by the way, we can remove the start and update method for now. We won't use them. Inside of the late update, we can create a target x and target y value. Let's write float target x equals. So our target x should be the player position plus the offset that we have. So let's create a target transform. So target dot position dot x plus x offset, of course. Let's create our target here. Elements, serialized field, private transform, target. Perfect. And our target y should be our y offset if the player is below the line. So let's initialize it at y offset. Now we can create a vector for a target position. So vector3 target position equals new vector3 with target x, target y, and -10 for the z-axis. Finally, we can apply that position to the camera. So transform that position equals target position. Target position. Here we go. Cool. So here is what we are going to do for testing purposes here. I'm going to prevent the player from moving along the y-axis, the x-axis, sorry, or should I keep it because we are actually moving along with it? So yeah, we can keep it actually. And if the target dot position dot y is less than the y follow threshold, so if the player is below the line, we can add a comment here. Player below the line. What we're going to do is lerp to the y offset position. So target y equals mathf dot lerp from the transform dot position dot y of the camera, so the current y position, to the target y or y offset. Actually, we can use it directly. So the interpolation value, we are going to use time dot delta time times back to rest, let's say, back to rest lerp. Okay? Inside your linear interpolations, make sure to always use time.delta time. This will make your game responsive across multiple devices, okay? Because some devices might have a frame rate of 60, some others 30, some others 10 if you have a very old device. But yeah, make sure to take that into consideration. Let's now create the back to rest lerp somewhere around here. Serialized field, private float, back to rest lerp. Perfect. And we should be good to go just for testing this situation. Of course, we are going to have another one after that if the player is above the Y follow threshold. So let's go back to Unity. Let's specify our target and set a back to rest lerp to I don't know, maybe 1 because it's 1 times time.delta time. Time.delta time is .016 if we are at 60 FPS. So yeah, let's try that first. Okay, I'm going to hit play. So the camera is following the player along the x-axis, which is perfect. Now let me grab the player. Let's freeze the position along the y-axis, sorry, so that I can move it by hand. Okay. Okay. So the player is above the line, I guess now. Where is my camera? Boom. Yeah, he should be above the line. So let's bring the camera up. Okay, I can't. Oh, this is because, yeah, we are lerping. Okay, so let's use transform.position.y first. Okay, now I'm able to move the camera up. Perfect. Let's bring it up. Okay, right here. Let's now re-enable the Y position. The player should go below the line, and now the camera is lerping towards it, which is awesome. So we can actually increase our lerp value here to 2 maybe, because it seems like it was a bit too slow in my opinion. So let's bring it up. Bring this up. Okay, let's make the player fall. Boom. Yeah, that's okay. Anyway, in the next one, we are going to implement the next logic and we are going to tweak the values just to have a better feel. See you in the next one. Welcome back, guys. In this lesson, we are going to tackle the second part of our camera movement. As to know, whenever the player is above the follow threshold that we've set up just before, actually. Here it is, in yellow. Cool. So let's open our script again and tackle the second situation right now. So let's first set up a lerp factor. So basically, I'm going to go through the method that I've implemented and then explain, okay? Because there are so many ways you could have done that. So first off, I like to set up a lerp factor. So float lerp factor equals mathf dot the absolute value of the transform dot position dot y and minus, sorry, the target dot position dot y. So basically, this is just the difference in, or the distance actually, between the camera and the target along the y-axis. Okay? So this is a value that I want because the further the player is from the camera, the faster I want to get the camera closer to it. Okay? Then I'm going to set up a lerp multiplier. So float lerp multiplier. This will be equal to mathf.pow. So I'm just going to emphasize that distance between the camera and the target because while testing, I found out that this was not enough. So mathf.pow, lerp factor to the power of y, let's say a certain factor. So y distance follow power. Let's create this variable now. Okay, let's grab it. Serialize field, private float. This. All right. And now that I have this lerp multiplier, I can finally get the camera closer. So target y equals mathf.lerp between the transform.position.y, so the current camera position, towards the target .position.y plus our y offset. And for the interpolation value, I'm going to use again time.delta time times the y, lerp multiplier, sorry, times a base lerp value. So because this might be equals to 0, like the camera can be at the same position of the target. So this can be 0. The 0 to the power of everything will be 1. So this will give us a value of 1 here, 1 times time.delta time. This is not optimal. So let's use a base y lerp. So base y lerp. Cool. Let's now create that variable somewhere around here. Private float this. Perfect. And this is our logic here. And again, as I've told you before, you can experiment with multiple ways of doing that. You could have used something like vector3.smooth damp from the current to the target velocity to the target position. And that's another way of doing things. This is another one. Perfect. Let's go back to Unity now. And let's set up our values here. So some values I found that work really well are 5 for the y distance follower power and 0.01 for the base y lerp. We can edit this later on. So now what I'm going to do to test that is allow the player to go above the line. So I'm going to start adding some platforms here. So let's duplicate the ground maybe. Okay, let's rename it platform. I'm going to change its scale to 2 units along the x-axis and let's say 1 along the y-axis. Let's center it so that I can move it easily. Okay, like so. Perfect. Let's move it somewhere around here, I guess. No, that's too high. So the height should be somewhere, something like 1, maybe. I think it's okay. Then later on, we are going to use a tile map. Don't worry about that. But 1 should be good. 7 plus, let's say, 3 along the x-axis. And let's add 1.5 here. So it should be 2.5. Okay. Let's do that again. So somewhere around here. Okay. And maybe here, and so on. So I'm just going to add some random platforms. I hope I will be able to jump over them. Let's try that. Let's first move them to the right, somewhere around here. Perfect. Oh, I did fall. Come on. Let's try again. Okay, boom, boom, boom. No, come on. That's not enough. So yeah, let's make things easier. I'm going to do this, 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 and this, and this, and this, and yeah, I think it's enough. Okay, let's try that. Boom, 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 boom. Okay, cool. The camera is following along. Okay, you see now it's really slow to catch up with the player. So that's bad. Let's edit our back to rest lerp here. Let's increase the value to, I don't know, maybe 10. So increase it by a factor 100. It should be enough in my opinion. So let's try this. Boom, 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 boom. Wow. Okay, almost there. Yeah, that's way better, indeed. Perfect. So this should be it for the camera controller. So what we are going to do in the next one is add the tile map. See you there. Welcome back, guys. In this lesson, we are going to add our first tile map. And I've decided to start with the obstacles tile map so that we can have kind of a game over, okay? We can reset the player position. All right. So what I'm going to do first is create a new game object to store all of these platforms here. Let's call it platforms. Okay, let's reset the transform. Grab all of these and drop them inside of here so that I can hide them. Perfect. Then I'm going to right click, select 2D object, tile map, rectangular. Cool. We have our first tile map. Awesome. So there are some small settings that I want to change here. First off, and lastly, actually, that's the only setting I'm going to change for now, is switch the game mode or the tile map mode to individual so that we can have our effect to work properly. Perfect. After that, we are going to change our cell size, but later on actually. Let's just keep it simple for now. So I'm going to rename this tile map cactus or obstacles. Yeah, obstacle tile map, yeah. Or obstacles TM. That's okay, yeah. You can call it whatever you want. Anyway, now we need to add some tiles to our tile map, right? So let's do that. Let's create a new folder right here. So create a new folder for our tiles. Perfect. So I can open the tile palette here. And if you don't see this window, you can simply select Window, 2D, Tile Palette. Awesome. I'm going to hide this or just diminish its size. You can hide it by clicking here. Perfect. And we are going to add our first tile right here. So let's open the sprites folder, tiles, cactus, drag it and drop it right here. And it doesn't work. Why? Because this is a sprite. Come on, this is not a tile. So let's create a new palette instead. Let's call it square dash palette, something like that. Or maybe just tile palette because we are already inside of the square dash folder or project, and create it. I'm going to create it inside of the tiles folder right here. Let's select the folder and here we go. We now have our tile palette. So we can now drag our tiles or sprites or sprite textures for them to be added to the palette. So let's drag the cactus right here and let's actually call it cactus, but not inside of the sprites folder. I want to drop it inside of the tiles folder. Boom. Perfect. Let's select our cactus and you need to make sure that your pixels per unit right here are equal to the resolution of your image. So if I check out the image, it's a 256 by 256 image. And it has a little specification, but I'm gonna talk about it later on. Okay. So this is one thing. We can now select the obstacle tile map, select the brush, select the cactus right here, and start painting. So right now you can notice that it's not that good. So the grid is a bit offset. So there are two possibilities here. You can either offset your grid or grab the player, move it up and move the ground up a little bit. And that's what I'm going to do because it's a way simpler approach. So let's do that. I'm going to grab the player, move it to 0.5, select the ground and move it by half a unit. So 0.5 again. I'm also going to change this. So 8 and -4 so that we have round numbers. Perfect. We can now bring our line a little bit above this value. So maybe 4. Yeah, that's okay. Perfect. And we can start placing our cacti. So here is one, and here is another one. Here is the third one. So let's first use 3 cacti, okay? And maybe we can have a wall after that. So that we make sure that the player cannot go further than this position. Cool. So this is one thing. Now our tile map do not have any collider. So let's add one. Let's add a tile map collider 2D. Perfect. Our player can now collide with the tile map. As you can see, we do have the green outline here. Awesome. Finally, what we can do is actually try this out. So let's hit play. Okay, let's jump over the first one, second one, third one, and boom, we are stuck. Good. It's working. Awesome. So now we need to turn this into an obstacle and bring back the player to the initial position. Okay? So I think that we should do that in the next one. See you there. Welcome back, guys. In this lesson, we are going to try and get the player back to the initial position whenever he hits a cactus or cacti. Yeah, I think cactus is one and cacti is multiple ones. Okay, so we are going to select our obstacle tile map and create a new layer for that because we do have the ground layer and we now need to create an obstacle layer. So let's create it. Obstacle. Perfect. Let's attach it to the obstacle layer or drop the obstacle tile map inside of that layer. And now we can add a new script to the player to detect game overs. So let's right click, create a new C# script, call it player game over, and wait for it to compile. All right, when it's done, I'm going to grab it, attach it to the player, and open it. All right, let's now detect collisions. So for that, I'm simply going to use the onCollisionEnter2D method and check if we've collided with the obstacle layer. So if collision.collider, this is the obstacle tile map, .gameObject.layer, this is the layer of the obstacle tile map, is indeed the obstacle layer. So for that, we need to use the layer mask dot layer to name method to convert an integer layer to a name equals obstacle, like so. Then we've collided with the obstacle layer. And I think that I need a parenthesis. No, nothing. So we are simply going to grab the player and bring it back to the initial position. For now, I'm simply going to write transform.position equals vector3.up, something like that. Okay, so let's try that. All right, let me jump. Boom. Let me not jump. Yeah, that's working. Awesome. So cool. Let's try and reach the final wall. Yeah, I got brought back to the initial pause. Awesome. So later on, we can add particles and a little bit of a delay just to make the effect more dramatic. Perfect. So now that this is working, we are going to add another tile map for our platforms. See you in the next one. Welcome back, guys. In this lesson, we are going to tackle the platforms tile map. So let's do that. Let's duplicate the obstacle tile map and rename it platforms TM. Maybe platform TM actually. Yeah, like so. I'm going to change the layer to default so that it doesn't interfere with our obstacles and keep the tile map collider so that we can actually collide with it. Then I need to clean this out a bit more. So what I'm going to do is press Shift and click it like so. Perfect. Just to remove the cacti from this layer. And it now has nothing to show, so no rendering. Then I'm going to add another tile to be used for the platforms. So I'm going to use the cobblestone one, which should be in the sprites folder. Yep, here it is. So I'm going to drag it and drop it here. Let's call it cobble tiles. Yep, right here. Cool. So the cobble sprite also have a certain particularity, okay? A specification that I'm going to tell you later on. But yeah, let's use it and make sure that the pixels per unit are actually 256 right here also. So I'm going to add some platforms somewhere around here, let's say. Yeah, I don't know. I'm just going to drop some platforms here. I'm not here for game design, okay? So let's select the obstacle platform and remove some of these. Okay, we can actually keep some cacti right here. It's going to be fun to prevent the player from jumping. Okay, let's go back to the platforms one. job things here, maybe something like that. I don't know. I'm not a game designer. Come on. So let's wait for maybe 3 thingies, something like that. Yeah, and like so. Here we go. Okay, so this is our new tile map. Let's give this a shot. Okay, jumping. Oh, nice. So seems like it's working, but I'm constantly rotating. I'm gonna leave you 5 seconds to understand why. 5, 4, 3, 2, 1, 0. This is because this is not tagged as ground. So let's change that. Let's select platform and switch it to the ground layer. Let's now hit play and it should work perfectly. I'm gonna test that. Okay, 1, 2, yeah, that's way better. Nice. But I can notice that this the spacing that I've used here is not optimal. So I'm going to increase that. So let's select the platform tile map again. Let's select the tile, the cobble tile, and I'm going to use 5 units for the spacing. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and another 5 here. Okay, should be good. Yep, this should be nice. So we can give this a shot again, just really quickly. Okay, let's try this out. Boom, boom. Let's keep pressing. And yeah, it's already way better. Awesome. So that's one thing. I don't know if you've noticed, but in here I can spot a little space between the cobblestones. That's really bad. So we are going to fix that in the next one by implementing the special effect of geometry dash. See you there. Welcome back, guys. In this lesson, we are going to implement our futuristic tile map effect, and it's going to be fun. Okay, so I already have attached the shader that we are going to use in the resources of the first lesson, if I remember well. So here it is. It's the tile map graph. So let's open it by double clicking it. Okay, perfect. It's pink in here, but doesn't matter. It's okay. Here is what we are going to do here. I'm going to maximize it first. It's actually pretty simple, but yeah, let me explain. We have the base texture of our tile map. So this is used for displaying the tile map. That's okay. We have a sampler to extract color information from it. And to apply our effect, the one that I'm going to show you, we are dealing with the UVs. We are editing them and modifying their values. So basically, we are just scaling the tile down. We are scaling it down to apply kind of a fading effect. You could have played with the alpha and so on, but that's a choice I've made here. You can add so many effects here. That's just one example. So we are first grabbing the position of the vertex, okay? Then we grab the X property of that position and subtract it to the camera position. We grab the absolute value to have a positive value. This basically gives us the distance from the vertex in world space to the camera position. So only along the x-axis. Okay, here we go. Then I'm using 2 smooth steps to scale it up or scale it down depending on its position. So if it's in front of the camera position, I'm scaling it up because we are getting closer to it. But if it's behind the camera, we are scaling it down. So here is the basic smooth step function. You can edit it to move it right, left, and wherever you want. Here you can actually change that to -10, let's say. Okay, so I'm going to bring it back. I can also bring this back, so from -10 to 5. Okay, I'm basically using 2 of these and just to scale it up and scale it down. As I've told you, it's pretty simple. You can use this website right here. So Desmos, it's really useful for setting up math equations for your shaders or for your code in general. Okay, so I'm grabbing the minimum of these 2, and it does give us the scale of our tile. One thing we can note here is that if we had simple game objects instead of tile maps, we could have used the vertices and scaled the vertices down. towards the center of the tile, of course. But I've tested that with the tile map and it's not working as expected. It's kind of giving us a weird result. I'm going to try and drop it here if I don't forget or if I can find something actually. But yeah, it's actually really weird. So that's the method I came up with. And this is why I've used the alpha or a bit of transparency right here, because it allows us to scale the tile down without having some weird artifacts. Okay, let's try this out. But first off, we need to remove this spacing because it's weird and it's not beautiful. What we can do is play with the sail size, so .99 or 98, let's say, like so, and it will disappear because it will bring the tiles closer. But this will actually cause an error as far as the player goes. You can imagine that right now we only have a difference of 0.02 units, now 0.04, 0.06, and so on. And at a certain point, we are going to reach 1, 2, 3 units of offset. And that's really bad. Have you noticed? Look at the difference between these two. That's bad, huh? So let's keep that at 1. And instead, let's select our cobble sprite, which should be somewhere around here, yep. And play around with the pixels per unit value right here. So what I'm going to do is set it to 253, let's say. Okay, let's apply. Yep, that's working. 254. What about this? I can still notice a little bit of spacing or transparency here. So 253 should be good. Perfect. We can try this out. Okay. Yeah, it seems good. Oh, come on. Why did I hit it? Yeah. Oh. I didn't do it on purpose, I swear. Yeah, that's way better. Okay, perfect. So this will also allow us to place our platforms correctly because we'll always have the same spacing between the platforms. Okay, we can apply the same thing for our cacti or cactus here. So 253, hit apply, boom. That's way better. All right, so that's one thing. Let's now apply the shader to the platform's tile map. So for that, I'm going to create a new material out of the shader. So right click, create a new material. Let's call it, I don't know, maybe tile map effect. Yep, something like that. Grab the platform game object here and assign this material. Okay, so right now everything is pink. Let's fix that. This is because this is a built-in shader and we are actually using URP here. While making the course, I used built-in and imported the URP by package right here. And yeah, it does cause some issues, but that's okay. I'm going to show you how you can fix that. We are simply going to right-click, create a new shader graph, and select URP Sprite Unlit Shader. And let's call it Tile Map Graph, like so. Perfect. We can open both of them. Let's save this one. Perfect. Let's select everything in here. So like so. Perfect. Control C, Control V right here. Okay, here we go. I'm going to drop these here. And we need to pass in all of our values. But first off, I'm just going to grab the RGBA and the alpha. Here we go. Is it set to yeah, alpha pre-multiply? Perfect. Sprite unlit. This is cool. So the settings seems to be all right. Now I need to add all of the values right here. And I'm going to try and give you that actually, so that you can have both shader graphs, one for the built-in pipeline and one for the URP pipeline. Okay, so I think I'm going to time-lapse this because I'm simply going to copy these values and paste them here. Okay, I think we should be good. So I'm going to try and apply that to the terrain now. So let's select the tile map effect material, grab this one, apply it, and yep, that's already way better. So now we can play with the UV scale. If we set it to 0, it does keep its original value. That's cool. We can play with this depending on the camera position. So right now we can notice that all of the effects, right, all of the tiles right here are actually scaling down. That's bad. So we can play with these values to have the desired effect. So let's set them to, I don't know, maybe I'm going to play with these a bit, time-lapse it, and find some good values for you. Okay, I think that these values are decent, and of course, you can always tweak them and adapt them to your situation. So let me grab the player, maybe the camera first. So 4, okay. And what I'm gonna do now is just play that for a bit and give it a shot, actually, even though it's not gonna change. But later on, we are gonna make it change depending on the camera position. Awesome. And you can see that the colliders are not impacted by the shader, of course. So yeah, this was it for the first part of the shader. Now we are going to edit it to take the camera position into consideration. See you in the next one. Welcome back, guys. In this lesson, we are finally going to apply the shader effect depending on the camera position because we've learned how we could make it work just out of the box right here, like so. But now let's add the camera position to this so that it's way better. All right. Let's create a new game object. I'm going to call it tilemap effect manager. Let's reset its transform and create a new script that I'm going to attach to it. So scripts, right click, create a new C# script, tilemap effect manager, and here we go. Perfect. Let's grab it. Come on. Attach it and open it. Nice. So we first need a reference to the platform tilemap so that we can grab its renderer, its material, and move or edit this vector right here, the camera position. So I'm going to grab it like so. So elements, as usual, serialize field, private render, and let's turn that into an array so that we can use multiple tile maps because we can already imagine that we will apply this effect to the cactus tile map, so the obstacle tile map, the platforms tile map, and or any other tile map that we would have. So let's do that. Tile map renderers. Perfect. Now we need to actually change these the camera position value. So inside of the update method, I'm first going to set up a target position. So vector3 target pause equals camera transform. That's actually not compulsory because we are actually taking into consideration the x-axis only in our shader. So let's add a reference to our camera right here. Serialize field, private transform, camera transform. Perfect. So for each render in tilemap renders, what we're going to do is grab the render.material.set vector. So the name of the vector is camera position, if I remember well. I'm going to check that right away. And we are going to pass in the camera transform.position. Perfect. This should be good. So let's go back to Unity and check if that's the right reference here. So let's select our shader, camera position. So underscore camera position. Awesome. We can actually close the previous one, by the way, and remove it. So materials, shaders, tile map graph, this one. Perfect. Let's rename this one and we should be good to go. So let's select the tilemap effect manager and pass in our camera. We also need to pass in the platform. And you know what? I'm also going to apply the shader to the obstacle tilemap. So let's grab the material and pass it in here. Awesome. We're also going to pass it in inside of the renderers array and hit play. Okay, nice. Whoa, that's so cool. Dude, I love it. Oh, come on. I can't die, so I'm gonna select obstacles. Okay, let's add some cacti somewhere around here. I think I can add them here. Maybe I don't know. Let's hit play. Come on, we are here to play. I think that's the limit here of the platforms. So let's try that. Okay, boom, boom, boom. Yeah, that's way better. That's so cool. Awesome. We've got the main effect working. Perfect. Okay, so now that this is working, let me show you a nice way of life improvement. So right now we can't spot any of our platforms nor our obstacles, and this is bad for level design. So for that, what we are going to do is actually change the max distance to 7,000, let's say, or 10,000, okay? So that it's really huge. That way we can spot all of our elements. But again, that's bad because we want to set it to 6 or 7 whenever we start the game. So let's do that. It's actually pretty simple. At start, what we are going to do is call the initialize method. So initialize, like so. Perfect. Let's create it. Private void, initialize, boom. Perfect. And in here, for each renderer, we are going to set the max distance property that we have somewhere around here. Let me show it to you. So tile map graph, come on. Here we go. So tile map graph max distance, here it is. We are going to set this at start. So let's change the string right here, and it's not a vector, but it's a float. Perfect. We are going to set it to the max distance, and we are going to create a variable for that so that we can actually change it whenever we want. So let's create a new header for the settings, serialize field, private float, max distance. Here we go. Let's now go back to Unity. Okay, perfect. Let's select our tile map effect manager and set the max distance to 7. And we should be good. Now if we hit play, what we should notice is these hide. And yep, that's the case. So cool. So it will make your life easier when making levels. Awesome. So in the next lesson, we are going to learn how we can make the player lose whenever he hits a platform from the front, like so. See you in the next one. Welcome back, guys. In this lesson, we are going to learn how we can make the player lose whenever he hits a platform from the front. Okay, cool. So here is our player. What we are going to do is create a new game object, and we are going to call it game over triggers, something like that. Yeah, seems logical. I'm going to press F to focus it. And right-click, create a new 2D sprite square. This is going to be our front trigger. Okay, so let me press T to resize it a little bit more. Something like that. Okay, maybe a little bit less tall. Yep, should be good. And place it at 0.5. Yeah, here we go. So this is our game over trigger, the first one. And I think that I'm only gonna add one, and you can add the second one by yourself. I was thinking about having another one at the top right here if the player hits a platform from the bottom, okay? You can do that. I think that Geometry Dash does that, so you're free to do so, but I wanna make the game a bit more fair. Okay, so here is our front trigger. I'm going to add a box collider 2D to that trigger and set it as trigger. Perfect. So in here, we are adding the box collider with the sprite renderer because the sprite renderer doesn't matter that much. I can remove it actually. Perfect. Here is the trigger. So now I'm going to add or implement the player game over script. I'm going to add the on trigger enter 2D method and implement it. Okay. So this does have a collider 2D as an argument, and it's named collision. So I like to name it collider because it's weird. This is collision because this is a collision, but this should be collider. I don't know. Anyway, so we've got a collider. We need a reference to this specific collider right here. So let's add it. I'm going to go back to my script here and create a new header for the game over triggers. So it should be components, something like that. Components, yeah. Serialize field, private, collider 2D. game over trigger. Yep, like so. So now that I have a reference to the game over trigger, I can check if this trigger has triggered this collider. Okay, so if collider dot is touching, we can use the is touching method to specify a collider, the game over trigger. If that's the case, well, that's a game over. So we can simply write transform that position equals vector3 dot up, like so. And because we are using this line twice, we can actually create a method for that. So private void explode, because we are going to make the player explode later on. So let's remove this line. Let's paste it here, explode. And finally, we can write explode. Awesome. Let's remove the start and update method because we are not using them again. In here, what we can do is use the expression bodied method syntax, like so. Boom and boom. Here we go. But later on, of course, we are not only going to apply this logic. We are going to explode the player, play some particles, hide the renderer, and so on and so on and so on. So it's good to keep that in mind. Yep. So now I'm going to select my player again and pass in the front trigger. And of course, as I've told you before, you can add or have multiple triggers here that you might use if you want to detect collisions with the top or the back, even though I don't know. Yeah, you can have some projectiles coming from the back, but at that point it would be an obstacle, an enemy, so you can use the simple box collider of the player. Yeah, you're free to do so. So yeah, let's try that. Do I have a way to collide from the front? Yeah, right here. I'm going to try and collide right here, or I can simply remove this for it to be faster, actually. So let's select the obstacle style map. Use the, I can use this brush or the eraser. Boom, erase it. Perfect. Let's now hit play. Okay, boom. Yeah, that's working. Awesome. But if I jump, of course, I'm not hitting anything. Yep, so cool. All right, so we got this. Now we need to implement the final touches of our game, I guess. So the game over, the explosion, some delay, stuff like that. Yeah, let's do that in the next one. You there? Welcome back, guys. In this lesson, we are finally going to add the exploding mechanic with particles and so on. So it might be a long lesson, I don't know, but yeah, stay tuned. It's going to be fun. Okay, so let's open our player controller right here. And we want to add an explode method. So I'm going to add it somewhere around here with the public methods, because we are going to call it from the player game over script. So yeah, let's create it. So public void explode. And I think that I'm going to grab it and drop it here instead before the methods that return a Boolean. Okay. So let's call this method from the player game over script. So I'm going to add an attribute again, require component type of player controller as usual, private player controller. Okay, and inside of the awake method, player controller equals get component of type player controller. Not like that, like so. Cool. So now we can change our explode method. So remove this and call the player controller.explode instead. That's better. This is where we are going to apply our logic. Okay. So whenever the player explodes, we want to do multiple things. So we want to hide the renderer. Okay, so I think that the player rotator will be responsible for that. So something like player rotator.explode, because he has a reference to the renderer, if I remember well. Yep, he does. So it will come in handy. Then we also want to freeze the rigid body. Okay. Maybe reset the rotation or stop, maybe reset the velocity, yeah. What do we want to do also? We want to play some particles. We can either play them here or have a player particle controller, something like that. But because our code is kind of small here or short, I'm going to add the logic right here. And finally, we want to revive after some time. So revive after 2 seconds. Okay. Yep, it should be it, I guess. But when we explode, we don't want to move anymore. So we should stop playing or stop moving using that velocity. So the first thing I'm going to do is add a player state. So this will be an enum. Let's call it state. It's going to be alive or dead, dead or alive. Okay. So let's create a variable of that type, state. Perfect. At start, the player is going to be alive. So state equals state.alive. Cool. What we can do now is prevent the player from jumping if he's dead, because whenever we explode, we want to set the state to dead, like so. You could either check if state equals state.dead return, or have a method that returns that. And I think it's actually cleaner. So public bool is dead. I'm going to use the expression body syntax here. We will return state equals state.dead. Okay. You could also return is alive. It's actually similar. So yeah. So if is dead, return. Same thing here. If is dead, return. Cool. So that's one thing. We can actually collapse these, jump, same thing. Actually, we won't be able to jump because we are dead. Okay, perfect. That's one thing. So let's now hide the renderer, okay? Or maybe freeze the rigid body because we are inside of the player controller. We have a reference to it. So rig.isKinematic equals true to set it as kinematic, and rig.velocity equals vector2.0 just to make sure that he's not going to move. Then we can also play the particles, but let's keep them for later on. But what I want to do is also revive after 2 seconds. So let's have a revive method, private void revive, like so. And we can call it after 2 seconds using either a coroutine or the update method or lintween. I love this library. So lintween.delay call after 2 seconds, we want to call the revive method. Like so. How cool is that? So now that we have this, let's implement the revive method because it's actually pretty simple. Inside of here, we are going to set the state to alive. We also want to reset the player position. So transform.position equals vector3.up times .5f. Okay, so half a thingy. And if you had a different start position for the player, you could store it right here inside of the awake method then, okay? But right now I know that my start position is this one. I can also re-enable the rigid body. So rig.isKinematic equals false. Perfect. Okay, so let's just test this first. And then what we can do is hide the render and so on, because I want to use events for that. Let's try and hit some things to die. Boom. Okay, so it's rotating, but it has revived. So cool. Boom. Yeah, kinematic and so on, not moving anymore. Waiting for 2 seconds and then reviving. Awesome. So the player rotator is still rotating, but we can fix that pretty easily. Okay, so let's go on. If we open our player rotator, we have a reference to the player controller. So what we can do is check if he's alive or dead. So if player controller.isDead, return. We don't want to rotate. Perfect. After that, we want to hide the renderer. So right here. So this is a private one. Yeah, let's collapse this, and collapse this. And add 2 similar methods. So private void explode, private void revive. Okay. So when we explode, we want to hide the renderer. So render that, I don't know, enabled equals false, or you can actually set the game object active property to false. And in here, when we revive, we want to render.enabled equals true. And we also want to reset the rotation. So render.transform.rotation equals quaternion.identity. or you could reset the local Euler angles like we've done right here. Okay, that's actually pretty similar. Perfect. Now we just need to call these two methods. When do we want to call them? Well, it's actually pretty simple, when we explode and revive, but we are going to use events for that. So let's use the system library using system. If you followed some of my other courses, you know that I usually set my events as static, but not now, because the player rotator is attached to the player controller, so it's a good practice actually to use it directly. So let's create a new header for these actions, public action on exploded, and another one when we revive. So on revived, like so. Cool. We need to call these events now. Let's call the onExploded right here. So onExploded.invoke. And same thing for the revive one. So onRevived invoke. Yep, like so. And now we can subscribe to these events inside of the player rotator to enable or to explode and revive. So inside of the awake method, player controller.onExploded plus equals explode, player controller.onRevived plus equals revive. And of course, we need to unsubscribe from these again in the onDestroy method. So onDestroy, let's unsubscribe like so. And we are good to go. Perfect. So now we should hide and display the renderer. So let's go back to Unity and check this out. I'm going to hit play. All right, let's test this out. Let's try and die. Boom. Yeah, the collider, the renderer has been hidden. Perfect. That's so cool. Now we just need to add our particles and we should be good to go. So let's not make this lesson that long. I'm going to do that in the next one. See you there. Welcome back, guys. In this final lesson of the first section, we are going to improve our graphics a little bit by adding some particles, a sky maybe the sun, some clouds, and so on. But come on, this is an artistic lesson. It's going to be chill, and you can actually do it your way. So let's start with the player explode particles. So I'm going to right click and create a new effects particle system. Explode particles. Okay. So I'm going to set the material of the particles to a circle because I don't like these square particles here, even though it's actually more logical to have squares. Yeah, let's keep squares actually. Yeah, of course. I'm always changing my mind. That's cool. So I'm going to set the simulation space to world. Perfect. Then what I'm going to do is I want them to be smaller first and colored with the same colors as our player. So let's change the start color to a random color between 2. I'm going to select the color, the player color, which is right here. And oh, come on, why is it? No, that's bad. This is better. And the second one should be a little bit brighter. Maybe this one. Yep, that's cool. I like it. Maybe we can have a black one. Yeah, in reference to the eyes. That's actually better in my opinion. Okay. I'm going to change the speed. Nope. I'm going to change the start size. And I want it to be a random value between .1 and .3, I guess. Yeah, that's actually a pretty decent value. Then for the emission, I'm going to set it to 0 and increase or add a burst of maybe 15 particles. So whenever the player explodes, it's going to emit 15 particles. Let's set the duration to 1 and the lifetime of these particles to, let's say, 2. I also want to scale them down as they live. So let's check the size over lifetime curve here, or module. I'm going to display the curve and select this one so that we start from the base size, so 1 in this case, and go back to 0 as they die, as the particles die, of course. Okay, let's bring this down and enable the collisions, of course, and we also want to enable the gravity first, so gravity modifier 1. Okay, let's allow the particles to collide with the world, and of course it's a 2D world, perfect. And I'm going to dampen them a bit, maybe 0.5. Yeah, that's cool. That's actually really nice. But I'm thinking about the fact that they will collide with the player because even though we've exploded, the collider is still enabled. So we might have to disable the collider at some point. Okay. Let's change the start speed to maybe between 10 and 20 so that we actually have an explosion. And the shape can be a circle, I guess. Yeah, that's cool. Maybe let's set the radius thickness to 0 so that the particles are emitted from the outside or from the bounds of the circle. I think that the speed is too much. So for between 5 and 10. Yeah, that's actually way better. Okay. So that's one thing here. Let's now play these particles whenever we explode. So I'm going to uncheck the looping checkbox and play on awake checkbox. Let's select the player and add a reference to these particles. Maybe somewhere around here. Effects. Serialize field, not serializable. Come on, serialize field. Private particle system, explode particles. So now let's play these somewhere around here. Right here. Explode particles.play. Cool. We can now go back to Unity, reference the particles, and hit play. Okay, let's try and lose. Boom. Nice. That's so cool. I love it. And of course, you can add as many particles as you want. You can even have child particles here. Okay? So yeah, that's one thing. Now let's change the sky color. So I'm going to select the camera and change the color, so the solid color, to a lighter blue maybe. Yeah, something like that can be nice. Setting the alpha to 1, but that's not compulsory. What about a green sky so that the player is not visible? No, that's not logical. So yeah, let's use this blue sky right here. Okay, and I'm also going to add some clouds. But first off, I think that I want to add a sun. So let's select square. Let's maybe move it somewhere around here, I guess. Yep. I'm going to set the order in layer to -10 so that it is rendered behind all of the other sprites. And set its color to a white-ish color, something like that. Maybe not that saturated. Yeah, let's diminish the saturation. Okay. Maybe we can actually make it a little bit transparent. I don't know. I'm not an artist. Come on. But what I want to show you here is that you can add clouds using a sprite sheet. So here is my sprite sheet somewhere around here. Yep, the cloud atlas. Perfect. I want to use these clouds for a particle system. So what I'm going to do is right click, create a new particle system and call it clouds, or maybe cloud particle system. Like so. Okay. So I first want to change the shape of the particle system. So let's switch it to box. Okay. Let's edit the shape of the box to something like that maybe and move it somewhere around here. Maybe a little bit above because the clouds should be in the sky. I think it's logical, isn't it? Let's set the start speed to 0 because we don't want to use this value. Instead, we are going to use the velocity over lifetime module and set it to -10, let's say. That's too much. So -5? That's still too much. -1. Okay, that's cool. We can change the lifetime of the particles. So let's set it to between, I don't know, between two constants. So between 10 and 20, something like that. Or maybe between 5 and 10, so that we can turn them transparent when they come to their end. So yeah, color over lifetime here. Let's set this to 0. Okay, and maybe it should actually start fading out when it's close to death, like so. Okay. I'm also going to reduce the amount of particles. I think I have too many. So let's set it to 1. Okay. And let's now use our atlas or our sprite sheet here. So we need to create a material for that. So materials, create a new material. Let's call it clouds particles. Yep. That's cool. Let's select the particle, mobile particles alpha blended shader. And let's pass in our clouds atlas. Perfect. If we now select our cloud particle system and assign this atlas, so this material, sorry, like so, you will notice the 4 sprites being rendered. That's really bad. So what we are going to do is first off change the ordering layer to -5. Perfect. And check the texture sheet animation module. So our texture is a grid indeed. And if you've noticed here, when I zoom in, the particles disappear, and that's kind of bad. This is because they are a child of the camera, and if we switch to 3D mode, they are really far. So what I can do is set the Z position to 10 so that they are on the same plane as the player. That was a little tip. Okay. Now let's fix the texture sheet thingy. So let's go back to our module. Okay. We have a 2x2 texture atlas, and right now it's changing the texture. That's not what I want. So I'm going to set it to 0 cycle, and the start frame should be a random constant between 0 and 3 because we have 4 sprites. So now we should see the four sprites being rendered. So that's 1, 2, 3, and the 4th one should be displayed at some point, I guess. Is it this one? Nope. So let's switch it to 4. Yeah, that's better actually. So yeah, indeed it was between 0 and 4. Okay. So they are a little bit too small in my opinion for now. So I'm going to increase their size to 5 maybe. No, that's too much. 3. But there are too many of them. So .1. Yeah, .5 maybe. Is that too much? I think that when we are going to move, it's going to be better. So let's try that. So I'm going to keep it at .5 looping, and let's pre-warm the particle system so that we do have some particles when we start. Okay, let's hit play, I guess. Okay, let's play for a little bit. Yeah. Okay, I see. They are now moving with the camera, so we need to switch the simulation space to world. Let's give that a shot again. Oh yeah, that's way better. That's what I like to see. Okay, cool. We are having a really nice, some really nice graphics here. I'm actually proud of myself. Awesome. So that was the first part of this course. I hope you've liked it. And if that's the case, please feel free to leave a review. It always helps. And yeah, let me know what you would love to see next for this course. See you in the next one. Bye-bye. Congratulations! Guess what? You've just nailed this course, and what a journey it must have been. I genuinely hope you've enjoyed the course and gained a wealth of knowledge throughout. Game dev is a journey that never ends. You will always learn something new. At times, it will be a tip that will help you save time, while at other times, it can be a system or game mechanic you can reuse in your own games. This is why I try and deliver a variety of courses so that you can have a broad view and be aware of multiple ways of coding, multiple game mechanics, tips, and tricks. If you're interested in learning more and considerably improve your game dev, I've attached a file with a bunch of discount codes for my other courses. Feel free to check it out. Have an amazing day. Cheers.